this is your notes for 3.5. We're going to be looking at different polynomials, factoring them, writing them as your sets of binomials being multiplied by one another, so your product of linear factors. And we're also going to be writing the polynomial given the product of linear factors. So if we look at our first example, we are letting p of x equal x cubed minus 3x squared plus x minus 3. You can rewrite this to where it's equal to 0. So x cubed minus 3x squared plus x minus 3 is equal to 0. And then you can factor it. If you couldn't factor it, you would do what we did in 3.4, where you find the factors of your constant, which in this case is the -3. And then you use your synthetic division. Whichever one gives you the 0 as your remainder, that's an answer. That's a 0. So with this one, we can actually factor it by grouping. So we group the first two terms, we group the last two terms. The first two terms you can factor out an x squared. The last two terms you can factor out a +1. So this becomes x squared times x minus 3 plus 1 times x minus 3 is equal to 0. Your two sets of parentheses are the same. So we're going to be given the x minus 3 times x squared plus 1 is equal to 0. That x squared plus 1 cannot be factored because it's a +1, not a -1, so it's not a difference of squares. So from here, set each of these equal to 0, so x minus 3 is equal to 0, x squared plus 1 is equal to 0. And then you're just solving. So the x plus 3, move the 3 over by adding it to both sides, and you get that x is 3. For the 1, move the 1 over by subtracting it from both sides, you get x squared is equal to -1. From there, with the x squared is equal to -1, take the square root of both sides. The square root of a -1 is I, so x is equal to plus or minus I. So you have three solutions here. You have x is equal to 3, x is equal to -I, and x is equal to +I. You can write these like we did in 3.4, where you have that x is the set of numbers plus or minus I, comma 3 in your brackets. So either one is fine. If we look at our next set of examples, we are actually finding the polynomial that's given to us as p of x or q of x with the zeros. So these are already solved for us. So with this, so like if we look at example A, we're finding the polynomial p of x if x is equal to the zeros that they give you, which are 2 and -2. So that means that x is equal to 2 and x is equal to -2. If we turn this x is equal to 2 into an expression where x plus or minus a number is equal to 0, we would just subtract that 2 over, so minus it from each side, and get x minus 2 is equal to 0. Same thing with the x is equal to -2. We would do the opposite operation to bring it over to the other side. So we would add it to both sides, and that gives us x plus 2 is equal to 0. Now that these are x minus 2 and x plus 2, both equal to 0, we can rewrite this as p of x is equal to x minus 2 times x plus 2. So we're literally just working backwards with these. From here, we FOIL it out since it's just a binomial times a binomial. The x times x is x squared. The x times 2 is positive 2x. The -2 times x is a -2x. And the -2 times -2 is a -4. We combine our like terms of the 2x and the -2x, which are opposites, so they cancel out. And that gives us p of x is equal to x squared minus 4. For example B, we're going to find q of x. So we're going to write this q of x is equal to, and then it gives us the zeros of -2. So x is equal to -2, 0, so x is equal to 0, and 5, so x is equal to 5. For the x is equal to -2, we're going to add the 2 to move it over, to get x plus 2 is equal to 0. The x is equal to 0. It's just x is equal to 0. And the x is equal to 5. We're going to subtract the 5 over. So we have that x minus 5 is equal to 0. So this is going to give us q of x is equal to x plus 2 times x minus 5. Now, I don't like it when it's written like this. I like my x that's by itself to be out front. So I would just rewrite it to where it's x, or q of x is equal to x times x plus 2 times x minus 5. To me, it's just easier that way. You don't have to rewrite it. It's totally up to you. From here, I'm going to start by FOILing those two binomials with one another. So the x plus 2 times x minus 5, I'm going to do that first. So it's going to give us q of x is equal to x times x is x squared. X times negative 5 is negative 5x. 2 times x is positive 2x. And 2 times negative 5 is negative 10. We combine our like terms of that negative 5x and that positive 2x. And this gives us q of x is equal to x times x squared minus 3x minus 10. The last thing that I have to do here is to distribute that x that's in front into that trinomial. So we're just going to multiply the x times x squared. It's going to give us q of x is equal to x cubed. Then the x times negative 3x is negative 3x squared. And then the x times negative 10 is negative 10x. So we just have q of x is equal to x cubed minus 3x squared minus 10x. For our next example, we have p of x is equal to x to the 4th power plus 2x squared minus 8. So we're actually going to be solving this one. We're going to find the zeros. So we're going to take x to the 4th power plus 2x squared minus 8. We set it equal to 0. And now we're going to factor. Are there factors of negative 8 that add up to be positive 2? Well, you have a positive 4 and a negative 2 that give you a positive 2. So yes. So this is going to factor out to be x squared plus 4 times x squared minus 2 is equal to 0. From here, you cannot factor the x squared plus 4. You cannot factor the x squared minus 2. The 2 is not a perfect square, so that's why you can't factor it. So we're going to set each part equal to 0 and solve. So it's going to give us x squared plus 4 is equal to 0, and x squared minus 2 is equal to 0. Working with the x squared plus 4 is equal to 0, subtract your 4 from each side. This gives us x squared is equal to negative 4. From here, we're going to take the square root of both sides. Remember, you have that negative underneath. So it's going to give you x is equal to plus or minus 2i. For the x squared minus 2 is equal to 0. Add your 2 over. That gives you x squared is equal to 2. And then take the square root of both sides. So you have x is equal to plus or minus the square root of 2. So you have 4 solutions here. So you can write them as x is equal to negative 2i, x is equal to positive 2i, x is equal to the negative square root of 2, and x is equal to the positive square root of 2. If you wanted to write them as a solution set, you could do that as well. For these, for 4 through 6, you're just writing the polynomial given the roots. So you're given what x is equal to. We're going to turn that into a binomial and then multiply all of our binomials together. With these, they are not given to you as f of x, g of x, p of x, q of x, any of it. So you don't have to necessarily write them as f of x is equal to. You can just state the polynomial. So for number 4, you have that x is equal to 4 and x is equal to negative 3. For the x is equal to 4, move the 4 over, subtract it from each side. That gives you x minus 4 is equal to 0. For the x minus 3, or sorry, x is equal to negative 3. Move your 3 over, add it to both sides. So that's x plus 3 is equal to 0. Both of these are equal to 0. So from here, set them into parentheses and multiply them out. So you have x minus 4 as well as x plus 3. Multiply them. The x times x is x squared. X times 3 is 3x. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. From here, combine your like terms. Your like terms are the 3x and the negative 4x. So this leaves you with x squared minus x minus 12. For number 5, you're given x is equal to negative 2/3 and x is equal to 1. If you work with the x is equal to negative 2/3, you're not going to add the 2/3 over. I mean, you could, but then you'd have x plus 2/3 is equal to 0. You have a fraction. Do you want to work with a fraction? No. So undo what you see. Fractions are the same thing as what operation? Division. So undo the division. Negative 2 divided by 3, opposite of dividing by 3, multiply by 3. So multiply each side by 3. That cancels out the 3's on the right side. So that's 3x is equal to negative 2. From here, add the 2 over. The 3x and the 2 are not like terms, so that gives you 3x plus 2 is equal to 0. This one's equal to 0. Hold on to it. Don't do anything else with it for right now. Look at the x is equal to 1. Set that equal to 0. Move your 1 over. Subtract it from each side. So x minus 1 is equal to 0. So you have your two sets here. So you have 3x plus 2, and you also have x minus 1. From here, FOIL it out. The 3x times x is 3x squared. 3x times negative 1 is negative 3x. 2 times x is 2x. And 2 times 1 is negative 2. Combine your like terms. This leaves you with 3x squared minus x minus 2. For number 6, you have x is equal to 5/2, x is equal to negative 1, and x is equal to negative 2/3. If you work first with the x is equal to 5/2, instead of dividing by 2, we're going to multiply each side by 2 to start with. So that's going to give us 2x is equal to 5. From here, subtract your 5 over. That's 2x minus 5 is equal to 0. For the x is equal to negative 1, easy. Move your 1 over by adding it to both sides. That gives you x plus 1 is equal to 0. Then for the x is equal to negative 2/3. Remember, multiply each side by the 3. That leaves you with 3x is equal to negative 2. Then add your 2 over to set this equal to 0. So that's 3x plus 2 is equal to 0. Your 3 parts that you have here. Easiest one is the x plus 1. You have the 2x minus 5 as well as the 3x plus 2. If it was me, I would FOIL out the 2x minus 5 times the 3x plus 2 first. To me, I just find it easier, but you don't have to. If you want to do it, work from the 2x minus 5 with the x plus 1, then FOIL or distribute in your terms to the 3x plus 2. You can do that. Totally up to you. So if I start this by doing the 2x times the 3x, this is going to give me x plus 1 times 6x squared. Then the 2x times 2 is positive 4x. The negative 5 times 3x is negative 15x. And the negative 5 times 2 is negative 10. If we combine our like terms here, this is going to give us x plus 1 times 6x squared minus 11x minus 10. From here, we're going to distribute the x and the 1 from the x plus 1 into that 6x squared minus 11x minus 10. So the x times 6x squared is 6x cubed. Then the x times negative 11x is negative 11x squared. The x times negative 10 is negative 10x. The 1 times 6x is positive 6x squared. Sorry, the 1 times 6x squared is 6x squared. The 1 times negative 11x is negative 11x. And the 1 times negative 10 is negative 10. From here, we're just going to add up our like terms. This gives us 6x cubed minus 5x squared minus 21x minus 10.